Alrighty then, everybody. Welcome to another 1 o'clock demo here at Arizona Science Center. My name is Maverick, and today we are going to be doing some really cool science, some extra cool science, possibly some really cold science today. And today we're going to be working with a really interesting substance that a lot of you probably know as dry ice. Now, dry ice, when you hear the word ice, you typically think water, right? You typically think it's going to be some frozen water, but water's not the only thing that can freeze, and dry ice actually isn't frozen water. It is frozen carbon dioxide. And what's really cool about it is it's a lot colder than typical frozen water, so typical ice, right? Dry ice is actually at about negative 110 degrees Fahrenheit. And I'm going to get some out for you, but anytime you're working with dry ice, you want to make sure that you are abiding by proper PPE, proper protective, personal protective equipment protocols, right? So you always want to make sure that you have your safety gear on. So I have my lab coat on, but super important things are going to be gloves. Now, because dry ice is so cold, you want to make sure you have gloves, some solid gloves that will provide good insulation. But these are just some nice leather gloves that will do a really good job of kind of protecting your skin from actually getting burnt by the dry ice. And then another thing I like to have on is these lovely goggles. You get to see how cool I look in these. Wow. So I'm gonna go ahead and get a big old chunk of dry ice here and bring it out. So this right here is our dry ice. I'll hold it right up to the camera. Now, the only reason I can hold this up to the camera is because, like I said, I've got these gloves on. Now, if you really look at this, you can see something coming off of it, right? Now, dry ice is in a solid state, right? Now, just like regular ice, water ice that you think of, right? Dry ice is in a solid state, but it's going straight to a gas. It skips that middle step, right? So with water, typically when it goes from regular ice, it goes from solid to liquid to gas. But dry ice, this frozen carbon dioxide right here, when it's in our atmosphere in general, it goes straight from a solid to a gas, and this process is called sublimation. Now, there's just a lot of really cool things that you can do with dry ice as it's constantly subliming and it's constantly going to that gaseous state and going all crazy, and the gas molecules are moving extra fast. So one little thing I'm going to show you here is I've got this graduated cylinder right here, and then I've got a big old container of water. So I'm just going to go ahead and pour some warm water into our graduated cylinder. And one thing I like to do, because I just think it looks cooler, is I also have some food coloring. So I've got a little bit of red food coloring. I'm gonna go ahead and drop that into the water, swirl it around a little bit, and it's like yellow food coloring, but I just think it looks a little cooler. I'm gonna go ahead and drop that in there, and I'm gonna get a smaller chunk of dry ice so it can actually fit in here. And when I add this small chunk of dry ice, we're gonna put it right here so you can see. You're gonna see it starts bubbling. Now, a lot of times on like Halloween, a lot of people use dry ice to make fog, right? You just literally drop it right into the water and it creates that fog and starts fogging up. And I just think it looks extra cool with this. So you can make all kinds of cool Halloween decorations if you change the colors to make it look like a witch's cauldron. But that's a really simple thing that happens. Basically, that sublimation, that dry ice is turning into that gaseous state, but it's happening inside the water, and these bubbles that you're seeing are the gas going all the way up to the top. Now, the actual gas that you're seeing right here is actually just the moisture condensing down and forming kind of into that, like that water vapor, not necessarily water vapor, but that vapor state. And this is basically exactly how clouds are formed. What we are creating are clouds in here. So it's like a fog, but it's essentially the exact same thing that we have when we create clouds. Now, one thing that's really, really cool too is I'm gonna add a couple more drops of dry ice chunks into here, and it's gonna boil up a little more vigorously. And then in this little container, I just have some soap, so some dish soap and some water, as well as some cloth, so some cotton. I have a shoelace in here. But when you run that shoelace, once it's soaked in kind of that dish soap, and you take that cloth and you coat the top of your container Let's see if I can make sure this works here. We're gonna turn that around. And you run it across the top here, and it covers the top. You get this awesome bubble. Now, the reason that happens is because that dish soap is trapping all of that gas inside, so it's kind of creating these big bubbles. And when the bubbles pop, it's a little windy out, which is why they're kind of flying all over the place. But when those bubbles pop, it just releases some of that carbon dioxide gas. Now, you don't want to breathe in too much carbon dioxide gas. However, in very small portions, it's totally fine, which is why this is totally okay. But we still have the proper PPE on just to be extra safe. But you can see it's constantly pumping these bubbles out instead of that straight fog. So you can pop the bubbles and create this awesome little gas here. So we're gonna push this off to the side and let this kind of boil away. Now, another cool demo I like to do is I've got a quarter right here. It's just metal, right? You can do this with most different like metals, but when it touches, when you get it on that dry ice, or on, basically what happens, you're gonna hear this. You guys hear that? So when you're touching that metal to the dry ice, what's happening is it's getting so cold, and kind of through that process of sublimation, the metal's starting to vibrate really fast, and sound is just vibration. So what you're hearing is that metal vibrating really fast because it's getting so cold when it's touching that dry ice. So that's why once it's warmed up a little bit, you put it back on and it does it again. Now, this will work with anything. One thing that's fun to do that I just didn't have on me is like with metal tongs. When you pick these up, little kitchen tongs, you can pick those up and using the metal tongs, and they just freak out and they just start yelling like that. It sounds like they're screaming in pain, but trust me, the dry ice cannot feel anything. Now, one of my favorite last little demos here is showing the process of that sublimation and something going to a gaseous state, and how the gases like to fill whatever space that they're in. So I've got this little water bottle here. I'm gonna go ahead and pour a little more water in here. Now, the water that I have in here is warm-ish, but it doesn't necessarily have to be warm water as long as it's not just like frozen. But I'm gonna go ahead and take some smaller pieces that I was breaking up with a hammer earlier, so that they'll fit. So I'm gonna go ahead and drop that in there, and you're gonna see that same process start happening. It looks like it's kind of boiling and the gases are going up to the top. Got a couple more smaller chunks here. Kind of break them into even smaller pieces. Remember, only ever do this with gloves on. You never ever want to touch dry ice without gloves on. But I'm going to put a few of those in there so you kind of see that gassing up. Now, my favorite little thing, this right here is a fancy science balloon, just a normal balloon. But because those gases are trying to escape out of the top, make sure I can do this. Now, because there's no dry ice on the top, I'm actually going to do this without the gloves. But you're going to take the balloon and you're going to put that over the top. And what happens is the balloon starts to inflate, right? Without touching it. It's filling this balloon just with that carbon dioxide gas and those water vapors there. That'll keep going. I don't know if this balloon's going to pop or not. I don't know how strong this balloon is. So I'm going to put these gloves on and see it just keeps inflating as those gases are coming out. Go ahead, you take it off of there, and then it flies away. And it flew away using water vapor and carbon dioxide gas instead of that typical the typical helium or oxygen or whatever that you'd be blowing into a balloon. Now, as a last one, we're gonna see if we can make an extra big bubble. So I've got this big container of water right here. So we're gonna put a bunch of dry ice in here, and we're gonna see how big of a bubble we can make. Ooh, that's what I like to see. So we're gonna make sure we soak this in. The wind died down a little bit, so hopefully it doesn't ruin our bubble. I'm gonna take this across the top, and we're gonna see if I can make this happen. Ooh, there it is. We get an extra big crystal ball, and it explodes. Whew. See if we can do another one now. What you can also do, if you don't want to cover the top and make those specific bubbles, you can take the actual dish soap and water and pour it in there, and what you'll see is you actually will start to get, hopefully, a whole bunch of dish soap bubbles. Now these get a little messier because these are kind of the mix of the dish soap and everything too, so they drop down and they still get a little wet. But we hope you had a lot of fun with our awesome, really cool dry ice demo here. We've got all kinds of other demos and everything. We're doing demos at we're doing our early learning lives at 9:30 every day, and we're doing our live demos at 1 o'clock every day here on Facebook. You can find out all kinds of information and see everything that we're offering there at azscience.org. Thank you guys so much, and have an awesome rest of your day, guys. Thank you.